This lesson deals with supplemental problem 8.4. You can find this problem in the ECE202 ebook in the Chapter 8 Supplemental Problems on page 3. In our last video, we converted from the time domain to the frequency domain. In this supplemental problem, we're going to go from the frequency domain to the time domain. To do that, we need to know the frequency of our original cosine function. Suppose it's 60 hertz, and that would be 377 radians per second. Suppose you have the following frequency domain results. Minus 5 plus J5, that would be in the second quadrant. Minus 4 minus J3, that would be in the third quadrant. 5 minus J12, that would be in the fourth quadrant. Minus J5, that would be in the J omega axis, in the border between the third and fourth quadrant. And then just 6, which would be on the real axis between the first and the fourth quadrant. To convert to the time domain, I need to find the magnitude and angle of these phasors. So the magnitude is the square root of the real part squared plus the imaginary part squared. And then the angle is the arctangent of the imaginary part over the real part. This turns out to be 7.07, and the arctangent of 5 over minus 5, and it's very important to know where the sign is. Here it's actually in the real part. It's going to put us in that second quadrant, and the angle will be 135 degrees. Now, if you get a calculator that can take this into account, you can just hit 2 buttons in and 2 buttons out. So my magnitude and angle in polar form is 7.07 at angle 135. Just put a cosine of omega t between the two. Second one, we'll take the square root of the real part squared plus the imaginary part squared, and then square root that, and that turns out to be 5. And the arctangent of minus 3 over minus 4, again, it's going to put us in the third quadrant at a minus 143 degrees. So our phasor then converts to the time domain as 5 times the cosine of 377t minus 143 degrees. 5 minus J12, 5 squared plus minus 12 squared, gives us 13 when we take the square root. Arctangent of minus 12 over 5, again, imaginary over real. And that's going to put us again into the fourth quadrant at a minus 67.4 degrees. So our time domain function then is 13 cosine of omega t minus 67.4. For the minus J5, we're going to take the square root of 0 squared plus minus 5 squared, which is just equal to 5. And then the arctangent of minus 5 over 0, and that's going to be a minus 90 degrees. So magnitude of 5, cosine omega t, angle of minus 90. And then lastly, for the real part of just 6, we have 6 squared plus a 0 imaginary part squared. That's going to give us 6. When we take the square root, and then the arctangent of 0 over 6 is just 0. So it'll be 6 times the cosine of omega t plus 0. And this is supplemental problem 8.4.